Greetings, friend. Timberlake here from Smart Hobbies, the channel that helps you turn a passing interest into a fun, enjoyable hobby. Today, I'm going to focus on Sudoku, in particular, how to use some advanced techniques to solve a hard Sudoku problem. I'm just going to pick a randomly generated Sudoku and solve that. Before we begin, make sure you subscribe to my channel and turn on notifications so you don't miss any new content. And with that, let's get started. Okay, right here, I'm just going to click click on a new Sudoku. I'll show all my candidates because that's what I'll need to solve this puzzle. With that, it's solving time. So when you're solving the harder ones, you're going to focus your eyes on the candidates now. It's not so much about scanning to where the givens are already filled in. So I can see a 3, 4, a 1, 4, and a 1, 3. That means that this has to be a 2 because I'll show this as a naked triple. So I can get rid of 1, 3, and 4 from all the other. In that case, that has to be a 2, and that has to be a 7. You have a 1, 3, 6, 1, 3, 6, 1, 3, so I can get rid of 1, 3, 6. That has to be an 8. And you can see here that this 2 is the only one in block 5, so we can get rid of that. That's a hidden single. The only place for 3s in block K is up here. That makes sense. 1, 4, 1, 5, and 4, 5. So we have another naked triple. So that means that has to be a 2, that has to be an 8. And you might just see the hidden single of 2 and 8 first. Since I'm looking at all the candidates, I tend to see the triples and the quads and the pairs first, and then I'll look backwards eliminate. And it works either way. Either way is okay. There's only one 5 across row 7, so that's a hidden single 5. You notice the 6s are locked into block 7 here in row 8, so that means that can't be a 6. There's a lot of candidates that I'll call a claiming pair. You'll see the 6s are either in rows 7 or 9 for the rest of this shoot, they call it. The 8's by itself, that can be solved. And then the 5s are limited to here, so it's kind of a claiming triple. So we know that can't be a 5, and that can't be a 5, but also their 5s right here will be a pointing pair. Do the same elimination. 1, 3, 5, 1, 3, 5, 1, 5 again. That's 6, hidden single, found it. The 2, there's only 1, 2 in row 1, so that has to be a 2 right there. We solved all the 2s. Great. Now, since that's 1, 5, and 1, 5, that has to be a 4, and that has to be a 3. 4, 7, 5, 7, 4, 5. Okay, great. This 5 is all by itself. 4, 7 pairs. Looking good there. And we got the 1 and the 5. We can solve a little bit more. 3, 5, 3, 5 makes that a 1 because this is a lot, naked pair. Also naked pair of 3, 6. We can solve that for a 1. Four, 5, and a 4, 5. So this is a naked pair, so that can't be a 4, and nothing else can be a 4 or 5. What does that leave us with? A 1, 8, 9, a 1, 9, a 6, 8, and a 1, 6. Okay. the 9. There's only one 9 left in row 9. So we can solve that. Two 9s here, 2 9s here. Okay. So I'm just going to go to start looking at my candidates and see if I can pull out any Xwings, any 2-string kites. Kind of get this along a little faster. Nothing with the 1s that I can use. Well, no, there is one. There is a 2-string kite here. So, 2-string kite, you're looking for a block. So in this case, block 7. And we have a strong relationship between these two because there's only 2 1s here. If this is false, that would be true. And then same thing, the same block right here. A strong relationship between that one and that one. Well, wherever these, so one of the, either this or this has to be 1 because these both can't be 1s. So wherever these intersect, you can eliminate a 1, which would be this cell right here, because this cell is seen by both of those two. And that is your 2-string kite. Okay. Here I'm looking, I don't see any eliminations just yet. I mean, there's some skyscraper type patterns going on, but can't solve with that. With the 4s, there's a finned Xwing that doesn't result in any eliminations. There's actually 2 finned Xwings. And row 2 and 5, and also row 1 and 4. But because of the fins, there's nothing to eliminate. Column 3 and 8 actually got another finned Xwing. Basically, this is a type 1 unique rectangle. So 3 5 3 5 3 5. So we can't be, if we solve this puzzle 5 3 5 and make that a 3, and we solve everything else at the end, we could go 3 5 3 5, and you'd have 2 solutions for the same puzzle. We don't want that. So we know, since this is the only cell that contains other candidates, that this cell has to be solved for either 1 or 7. So we can eliminate the 3 and a 5 from that cell. So also, we have a 3 5 here. That's a naked pair. I can get rid of the 3s and the 5s. This is probably why I was a little slow in recognizing that as a unique rectangle. Now looking at our fives, no more eliminations there, but that was helpful. Going to the 6s. No eliminations there. To the 7s. Nothing there. To the 8s. Nothing there. To the 9s. Nothing there. We have a decent amount for XYChains. I think there's going to be some XYChains that we can work versus, XYWings that we could work here first. I don't want to get too much to the XYChains. I kind of use those as more of a last resort. So I'm just scanning through here, so I don't miss anything very obvious. Okay. I don't see anything too obvious being missed. So I guess I will go here. And I want to see if we can do some XYChains to kind of make that 1 elimination or 2 that will really crack this puzzle open. So needing to solve for 4s isn't really going to help me too much. So I need to look for maybe 7s. Because if I can get down to this 7, which I can't, that would help me though. Okay, so we do have a XYChain elimination, so we can start here at this 7. So 7 goes to the 4, 4 goes to the 7, 7 goes to 5, 5 goes to the 4, 4 to the 5, and 5 to the 7. So either this or this has to be a 7. So any cells they can see, we can eliminate a 7. So we can eliminate a 7 right there, which means now the 7s are locked. They're not locked. But now we have a 1, 3 pair, so we can get rid of the 1 and the 3 from that. Get rid of the 1 from that. And you just create a 4, 7, 4, 6, and a 6, 7. And now you have the 6, 7. So we can make it pair. Make that a 1, 3. See, now we're making a whole lot of 5 value cells, which is great. That will help us solve this puzzle. Okay. Can't really do any solvings for 8s, but maybe some help with 3s. 1, 3. 5, 5, 3. No, can't. Don't need to solve for that just yet. Alright, well, let's go back here because I eliminated quite a bit in the 1s. And I'm kind of toying with this remote pair idea because you have the 1, 3 pairs. But they don't, the tail end can be 1 or 3. If this is a 1, that's got to be a 3. You can eliminate whatever they both see, but there's no elimination to be made. So now I'm looking to see if there's something else I can make because we eliminated quite a few candidates here. So we do have now an Xwing, and that will crack it, I believe. All right, so here's our Xwing. These cells with 3s, only 2 3s there, so it's got to be 3 and 3 or 3 and 3. So we know we can eliminate 3 from there. That has to be an 8. That has to be a 6. And now that has to be an 8. Let's get rid of that. Makes this a 1. Makes that a 9. And how much further can we go with this here? 3 and 6. 1, 3, 1, 3. Okay. All right. Should be really close here. I feel like I'm missing something. Like we're almost to bug +1 configuration. We have +2. Ooh. But the easiest way to do that would be through another XYChain. All right. again, I'm going for logical solution here. I don't want to just start guessing because I want to show that you can solve these puzzles logically. It's a lot of fun. So there it is. The 5 sevens come down here means that that can't be a 7. That has to be a 6. That was a little bit easier for me to see. That's a 9, 4, 7, 5, 4, 7. These are all going to be naked singles. Okay, used quite a bit, some different techniques there. Sudoku is solved. How did you do? Let me know in the comments. Did you find a different method that made it a lot quicker for you? I would love to know about it. Also, was there any screamer cells? Anytime I was on there, you go, please, Timberlake, you've got to see this. Also, you let me know the time frame on that. If you want to see any particular puzzles, I'd be happy to pull some down. Sometimes I do daily diabolicals. I'd also be interested in doing, other hard expert puzzles. I'm kind of working to get even better at Sudoku. I just want to make it enjoyable for you. If you want me to do some more terms and explain those and certain techniques, I'm happy to do that. Until next time, thank you so much for watching.